Okay, so my name is Lloyd Spencer. I'm from Carbon Meta Technologies, and first I want to thank Priya for her vision, really her dedication to the two key things. Let me see if we can put that in a slide. So there you go. Dedication to the issues around environmental sustainability. It's the sustainability part that's the most difficult part, I find. So with that, oops. There we go. So as you know, we've all heard about how plastic is the challenge, it's the problem. And there is about 35.7 million tons just in the United States. You can almost multiply that times around 10 and you get close to the amount of plastic that's being produced and turned into waste that doesn't get recycled back into the system. And in fact, when you look at the real numbers, in fact, I was talking with somebody from Las Vegas, it's somewhere around 7% over there. In other parts, some people claim as high as 10%, so I've seen that number. And you've all heard about the plastic waste in the middle Pacific Ocean, which is where some of that ends up after all. So we really have about 8.3 billion tons, globally, it's thought. So at the end of the day, we've made quite a mess along the way. Another challenge is on the carbon dioxide front. So we produce about 36.4 billion tons of carbon dioxide, and that was in 2021 alone. About 18 plus billion tons remains in the atmosphere. The rest goes into the water, it gets reabsorbed, and it turns our oceans a little bit acidic, and then there's problems around that. So the atmospheric carbon dioxide in 2021 was 413.2 parts per million, plus or minus 0.2, I suppose. But it really is becoming a problem. And really, when you look at the amount of carbon that we have in our environment, you really have to kind of put it in the context also of what percent of our planet is carbon, and therefore how much have we caused to be the problem. So just out of curiosity, and this is something that turned up in I do tutoring with high school and college students, and one of them blithely asked me, so what percentage of the planet is carbon? And I said, I don't know off the top of my head, which is the smart thing to do when you really don't know. But I'm just curious, just a couple of guesses out there, because I did kind of guess and I was wrong. But any guesses on what percentage of our planet, the whole planet, is carbon? Yeah.
You mean not just atmosphere?
Oh, everything, the whole planet.
I'm going to just
Yeah.
27%.
Got it. Well, we're 18%, by the way. So you and I and all living things for the most part are around 18%. Plants are a little more, we're a little less, but we're all about 18 some odd percent. So it's way less than that, I'll tell you right now, for the planet. I'll give you one other hint. The number one element is actually oxygen. So believe it or not, the Earth is made up of mostly oxygen. So now, give me another guess. Just any guess will do.
4%.
4%, 1%. I would say keep going down. Yeah. 0.5%. Okay. One more guess. 0.2. It's actually 0.03% of the planet is carbon. That's it. 0.03. It's oxygen first, silicon next. I think it might be magnesium or calcium. I can't remember, but it's neck and neck somewhere in that range. That's it. 0.03% of the planet is carbon. So we've done an amazingly good job of scuffing up the carbon that went back up into the atmosphere. So we really have the plants and the fungi to thank us. Well, we have to thank them, I should say, for since the Cambrian period, pulling all that carbon dioxide out of the atmosphere, putting it into plants. They get turned into detritus. They go down and they turn into oil and coal and whatever else. But it's been about 500 million years of taking the carbon out of the atmosphere and putting it back onto the Earth. And we've done a remarkably good job over the past, I'd say, 200 to 300 years of scuffing it up and putting it back up in the atmosphere. So that kind of puts it a little bit in context that, in fact, the real challenge isn't really plastic waste. It's a challenge, no question. The real challenge is not CO2 emissions per se. It really is us, okay? We are really the real challenge. And it's not for lack of intent, right? It really is our inability to understand and quantify how our daily actions can make a difference. So when you have a piece of plastic and you, any kind of saran wrap or something, and you want to know, what do I do with it? And most people say, let's recycle it. And then you look at the label and it says, no, the company doesn't recycle that, so you put it in the trash. So now you've participated in the problem, but you really don't know what to do next. And that really comes down to, it makes it very hard to evaluate exactly what are the choices that we should be taking, because we really don't know what to do. And so it's our inability to connect the dots. And I'll tell you a couple of stories here which actually lead people to start making the right decisions, and it's kind of remarkable when it does happen. So how can we connect the dots? All right. I'll start with one example of me starting to work with prototyping out a process that it started with a conversation with the University of Oxford, where they said, hey, we actually can take plastic, like this is the plastic over here from the clear plastics like these. This is PET plastic. Well, you grind it up and it turns into these flakes like that. Well, it turns out University of Oxford had taken a technology using microwaves and using a catalyst with that, and then turning that into a carbon black. So they noticed that it produced all this carbon black. And it turns out the majority of it was, to their surprise, by the way, this was not entirely by design, right? But it was to their surprise that it was carbon nanotubes, maybe some graphene, and definitely some graphite in there. And it turns out all these can actually get used in various products. This can get used in the anodes of batteries, for example. The carbon nanotubes can actually be used in epoxies and plastics to make them conductive or far more strong. So you can actually now go ahead and take a waste plastic, transform it very efficiently, as it turns out. If there's one thing I've learned about microwaves, it is there is nothing intuitive about microwaves, nothing. You ask a microwave engineer, how much of this do you need, how much energy do you need, and they say, you know, it's really not intuitive, you just have to try and see if it works. And then you go ahead and you experiment, you refine it, and you eventually get it to a point where, as we have found, you can actually, and one other point I should have brought out was, you get hydrogen out of it as well. So it's not just carbon nanotubes, it's the hydrogen. You can also use that hydrogen to go generate electricity and go power your own system. So it ends up being a net positive for the energy you put in, you get more hydrogen energy back out. So it's a phenomenally good process, and Oxford University deserves all the credit for finding this. And interestingly, when I had my first discussions, they were all excited about the hydrogen. And I said, well, that's part of the news. The other part is that financially you can make this work with carbon nanotubes, which made them even happier. So right now we're scaling this up. But I'll point out that that little coffee stand over in Mukilteo, Washington, when I went to them originally and I said, hey, I would like to take some of your plastic and to be able to go ahead and do some experiments in turning these into carbon nanotubes, which they had no idea what that was, but they were very excited about the hydrogen, though. And they said, we don't use that much plastic, though. And I said, well, then give me what you have, right? And so it started with, well, here's some milk bottles, and that's pretty good. And then Abby, who's over in Mukilteo, she went ahead and she started counting. She started actually picking up the plastic. So not only is it the plastic water bottles or I should say the milk bottles, but it's also the plastic water bottles for the mineral water they serve. And it's also the crisps like this, which is also plastic, which is called BOP, B-O-P-P, which is biaxial oriented polypropylene. But I think it's well-deserved for the person who invented it. They should get bopped on the head because they made quite a mess in the process. So as it turns out, they started really collecting it. And they went from a couple of bottles here and there to then going to packing up about 10 pounds per week. Whoops. I think we lost our slides completely. Oh, thanks. There we go. All right. So then we started working with Zaloop to go ahead and start tying it all together with blockchain. So with blockchain, we went ahead and we started looking at how we can tie it together where somebody donates their plastic, it gets counted, turns into a token, and now we can go ahead and apply the profits that we bring to that back into the blockchain. So we've been finding that they have about 13,000 users worldwide in over 150 countries, and it's been working rather successfully on a very small scale, and now we're going to start increasing this. I've also had some inquiries about using coal, for example, as well as other organic materials to do the exact same thing with hydrogen in carbon nanotubes. Similarly, with connecting the dots, you've all heard about the cement industry being a problem. So it turns out that we found a way to take cement waste. So the waste that comes out of the cement plants, which looks like this, people call it cement kiln dust, as well as you can take some of the waste material that comes out of the iron producing companies. So they produce a slag. You can take some of that as well. And these are used today in the cement industry in small amounts. But if you take these, plus you go ahead and use something like limestone or other stone, you can actually turn that into a cement. And it's interesting, that's good because you're taking waste. But what's more interesting is this actually absorbs carbon dioxide. It takes carbon dioxide out of the air and puts it back in as calcium carbonate, just like the seashells, exact same thing. So now we said, well, how can we turn this into a blockchain opportunity so we can track the carbon dioxide? So we decided to work with OurChain as one company who have a very efficient blockchain. And their blockchain will scale very high. There are some other vendors here too that also use blockchain as well. And we encourage, in fact, we'd love to work with more companies in this area so we can turn blockchain into a carbon credit. And that carbon credit and those tokens can then be traded. You can also attach NFTs to them, and it will encourage people to go ahead and buy products that absorb carbon dioxide. So at the end of the day, these tools will end up encouraging people to deposit their plastics, no matter what they are, into the right place. And as well, they'll encourage people to buy products that absorb carbon dioxide instead of emitting carbon dioxide. And so at the end of the day, blockchain, I think, is going to be used as a catalyst for ecosystems of companies and people so they can be incentivized for doing the right thing for the environment. It helps them make the right choices. The blockchain advantages are all the things you've heard about today. What I especially like is that you can start using these things as ways for gamification and even coupons, for example. So if you have a coupon that can be used in the form of a token and you can resell that token, if I can go ahead and I can add funding back so you can get a I'll call it a commission back through your blockchain, that's going to make it more valuable, and therefore people will want to actually recycle more plastic. So it's a positive feedback loop. And last is on the trust and verify. What I see is that we're going to end up having auditors to work with us so they can go ahead and look at how much carbon dioxide actually is absorbed with some of these products, how much of the carbon nanotubes and hydrogen we can get out of plastics, so that can be used as a way that you know that the blockchain actually is truthfully doing what it's supposed to do. And with that, I wanted to thank you for your time and thank you for your attention.
Thank you very much.
Are you taking questions?
We actually have ran out of time.
Okay, no questions.
You know what? Let's take one. Go ahead, please.
I actually have a professional relationship with OurChain, so good move.
Thank you.
OurChain Co-op is amazing. My friend George Gilder is writing a book and another book,
Right.
one of many, And one of the themes is going to be about graphene,
Yes.
okay? Are you working in the graphene sector as well?
Yes, so some of the material we're producing that's going to come out of this is graphene, and
Yes.
the other is we've had people that want to take some of the nanotubes and turn that into a graphene. So the
Yes.
answer is a definite yes, and I'd love to be working with you on that.
Okay, well, let's have lunch together.
That'd be great.
Because George is a big guru from the semiconductor wafers to life after television through life after Google,
There you go.
and as well as in the blockchain sector.
Excellent.
So he's a big fan of conversion of waste into graphene, and apparently it's very valuable, this graphene.
Yes.
So you're cleaning up you're ending climate change as a byproduct of
Yes.
of making a lot of money.
Yeah, yeah.
I kind of like that as the chairman of the World Capitalist League. Thank you.
Thank you. Thank you.
Excellent, thank you very much. Do you need these samples?
Yes, I do.
These are really cool samples if you get a chance to look at them.
They'll be right out there. You can actually take a look at them. Thank you.